Good morning, students. So today we'll continue with the functions of the operating system. So today we'll discuss device management, file management, and file production. Okay. So in the previous video, I wrote on memory management functions. So theoretical details are more. Okay, but there are some technical words, and since this is the internal working function of the operating system, okay, so theoretical explanation is enough, so that's why I uploaded the tutorial video so that you can see the images also and understand. Okay, so the pictorial diagram is not the exact working style of the operating system, but from there you can at least grasp an idea, get an idea about how the operating system is managing, right? So for today's video also, okay, I've copied it from the textbook, okay, so the explanation is in detail, okay, but along with that you also check out some tutorials, okay, to get the better understanding about these functions of the operating system. So theoretically I'll try my best to make you understand, but there are some technical words, okay, which it will take some time for you to grasp. So let's move on to the next today's topic. So here I have clicked an image of the textbook, okay, so the discussion is about device management. So after the in the memory management functions, okay, we have discussed about single contiguous allocation, partition allocation, page memory management, and demand page memory management, right? So uh, in so the memory management was the first category of the operating system, okay. So second is the device management, then we have the processor management and the file management. So today we'll see device management and file management, okay. So under the device management, it is written there, the management of the input and output devices like keyboard, printer, disk, card readers, and control units comes under the device management. So the peripheral devices, the hardware devices, okay, that are attached to your computer, okay, so that is handled by the CPU, the main memory, okay, all these devices, okay. So the operating system is crucial, okay, for maintaining the device also, to interact with the user, okay, with the CPU, the main memory, like that. So since the operating system is a system software, keep that in mind, okay. So the device management part of operating system manages and utilizes these devices in an efficient manner, okay. We interact with the computer hardware, okay, with the help of the operating system. So since the system software, and with it we interact with the application software also. So uh, to interact with the computer hardware, be it your printer, your monitor, keyboard, hard disk, card reader, okay, all those things, okay, the operating system has a set of software programs written under it, that is the device management, okay. So so with this you are able to utilize all these devices in an efficient manner, okay. So the basic main function of device management are using special mechanism has to keep track of the status of all the device, okay. So with the help of this device management, okay, the status of all the devices are being kept track of, okay. What is the keyboard doing, okay, is it attached or not, what is the hard disk, okay, the monitor, okay, the printer, is it active, is it on, all those things. It the device management monitors that. Is your printer switch on, switch off, like that, right? It monitor. If you give a command to print and the printer is not switched on, the device management detects that one, like that, right? If you if you want to type but there is no keyboard like that, right? Or no mouse like that. So when request comes, has to decide on policy to determine who gets a device when and how long, right? So the request from the CPU or the main memory, when it comes, okay, uh, it will execute on where it should be allocated, okay, to the keyboard, okay, or to the, say, like the printer, okay, the job assigning. So that is on assigning a device to the job, okay. So if the keyboard, you're typing something from the keyboard, okay, the device management, okay, gives control to the CPU, okay, to the main memory to execute. The control unit sends signals to the main memory, okay, to extract whatever information is being sent by the keyboard, like that, okay. And if it is to be saved to the hard drive, hard disk or not, okay, like that. So assigning a device to two jobs. When the job is over, deallocating the device and changing the status information, okay. So once you have finished typing from the keyboard, okay, or like once you have finished printing out from the printer, okay, then the device management, okay, takes care of deallocating the device. That means the memory that the memory space that has been assigned for doing the work, okay, is being uh, removed, okay, or is being kept vacant, okay. So the memory space that has been filled up to by the resources, to do the resources, okay, is being vacated, okay. So the CPU and the main memory, okay, so the main memory space is vacated again, like that, okay. Now, the module that keeps the track of the status of device is called input-output traffic controller. Okay, all modules associated with the operation of a single device are called input-output device handlers. So all the input-output devices can be classified into any one of the following three categories. So we have dedicated, shared, and virtual. Okay, now there is clearly explained there. A dedicated device is allocated to a single job for the job entire duration, okay. So here we have a dedicated device, okay. A dedicated device is one which can do only a single job, okay, till that job is being completed, till the job is being complicated is being till the job is not completed, okay. That device will remain dedicated to that particular job only, and after that only, okay, it can carry on with the next job, like that, okay. So there is no interruption in between. Like example, you have a printer, right? So you have a output device printer. Now this device by nature falls in this category. There may be a situation where several users wants to use the printer at the same time. Now if it, so it is not possible that everybody suppose like in an office there is a printer and several users systems are attached to that, are connected to that printer, right? Now if suppose two users are trying to access the printer and giving the command to print out, now it is not possible that the printer will both the uh, file print out both the files at the same time, no, right? Otherwise, if you imagine how it will come out, it will be a mixture of data, right? So that is not so, that is not possible, okay. So if it is not dedicated, imagine the output produced by the printer. Because of this reason, the printer is a dedicated device, okay. So I hope that from there you have understood what is a dedicated device, okay. Now shared. So shared device, the devices like disks, okay, your hard drive, okay, drum, that was earlier on it was a memory storage device, okay, drum drive, okay, and other direct access device are shared device because these devices can be shared by several jobs at a time. Your example is your disk drive, right? You can do several jobs at a time. The CPU can make access to that, the main memory can access information from that, okay. Whatever you then whatever data you're working on, and an application software, it can be accessed from the hard disk, right? So multiple jobs it can be done at the same time. Okay, so what happens is that your disk drive gets shared. Okay, unlike the printer, in case of the printer it can do only one job at a time, but in the case of your disk drives, okay, it can do multiple jobs since it can be shared, right? Another user can access data from the hard disk while the disk is doing a different job, like that, right? So that is the concept of shared. Okay, so in case of the say in case of the CPU and the main memory, okay, they are considered as uh, they are they can be considered as MDable. Okay, they can be MD'd, right? Pre-MDable. So like see, a user program that occupies a particular range of location in the main memory may be removed or preempted by another program, right? So in case of CPU, okay, CPU, you keep in mind that it has a very high speed temporary memory location also inbuilt in the CPU, right? So CPU is the most pre-emptiable resource on a computer system. It will do a job very fast and then execute onto the next resources, like that, right? So the control of the CPU can be transferred from one process to another, like that. Okay, however some resources are cannot be emptied like that, right? Like the tape drives example, like that. Now now coming back to the virtual, some devices can be converted from dedicated device to shared device, like card reader, right? Now card reader is also a dedicated device, but at the same time it can also be a shared change into a shared device. So like example, the technique which is converting the dedicated device to shared device is called spooling. Okay, so maybe you might have heard the word spooling. Okay, in short it is called a spool. Okay, it stands for simultaneous peripherals operations online. Okay, simultaneous peripherals operations online. You can check out Google search it for more details on what is spooling. Okay, so it is a technique used to reduce the speed mismatch between the CPU. CPU is very high speed, right? And some like low speed devices. It may be a dedicated device, it may be a virtual device, it may be a shared device, right? Okay, so the speed of the speed access from the disk in the CPU is also different, or from the keyboard, like that, right? So since CPU is a very high speed uh, uh, access, right? So what will happen is that spooling it adjusts or it reduces that speed mismatch between the CPU, okay, main memory, and those devices. Okay, like suppose like see a if the suppose like if you want something to be printed out, right? And then so what happens is that since the printer is a dedicated device, okay, so it will keep on continuing that work till it gets printed out. Now let's say since printer is a dedicated device, but yet it can be shared with different computers, right? However, that it does not mean that it is a shared device. It is a dedicated device since it can do only one job at a time. But it can that printer can be shared to multiple users. So another users give a command to the printer. So what will happen there? Now in that case, uh, the second user's file does not get printed out immediately, right? So what happens is that okay, the CPU, since in the case of the CPU, okay, since it is very high speed, right, because it is giving the command to the printer to access it and then to print it out, right? But in the case of the printer, since it's dedicated device, so it is still continuing with printing the first user's data. So what happens is that in order to reduce the execution time, okay, so what happens is that uh, in case a program sends to the printer, okay, so the printing has to wait So it before it can transmit, okay, the next line, the program to be executed slowly. So to speed up that program execution or the printing execution, okay, so the next user's, okay, data printout is routed to a faster device or such like a hard drive. So in the hard drive, okay, it is temporarily stored until the first data gets printed out. Okay, so that is called as pooling. Okay, so same way like in the case of the card reader also, okay, the technique which is converting the dedicated device to shared device is called spooling. Okay, so that I've explained the concept of spooling. Okay, I hope you have understood. So like a spooling program, okay, can read and copy all card information onto a disk at high speed. Okay, hope you got it. Okay, so while the data is being copied on or read from the card reader, okay, the spooling program, okay, will read that and copy all that onto a disk drive at a very high speed. Okay, that's why you are able to extract the information faster like that. Okay, so later when a process tries to read the card reader, the spooling program intercepts the request and converts it to read from the disk. Okay, here a dedicated device is converted to a shared device, changing card reader into many virtual card readers. So I hope from there you have understood. Okay, so from the card reader, the data is being copied onto the hard disk. Okay, and if anybody wants to access that, okay, then the access request is sent from the read to the disk like that. Okay, so that is taken care by the spooling, okay, in case of the virtual devices. Okay, so those are the three things under device management. Now we come to the file management. File management, we have been doing this uh, almost whenever we copy file or do like that in the hard disk. Okay, but without knowing what is file management. So file management aspects of operating system is one that deals with the management of data and program which resides on uh, secondary storage device. Okay, on the secondary storage device, not on the primary. So file is a collection of related information defined by its users. Okay, so that it defines the file collection of related information defined by its users. It is named and referred to by its name. So you create the file, right, and then you name the file, and then yes, you can make modifications to the file also. Okay, and at the same time you can delete the file. So those are the things which is possible under the file management. Okay, so files are normally organized on the directories for easy access. So under file management, what happens under the operating system? How does the operating systems takes care of the file? Now normally uh, when you're installing a software, what happens? A directory is created. Under that directory, uh, similar files are kept, right? When I say a directory, I mean in terms of folders. Okay, if you're installing a software, it goes to the program file, it goes to Windows, or if you're installing a game CD, okay, movies goes to the movies, audio goes to the audios, like that. Videos goes to the videos, right? Different types of files. Images goes to the image folder, like that, right? So similar files kept in similar folders, like that, right? So the file management takes care of that. Okay, since files are shared among multiple users, it must be protected against unauthorized users. Okay, so at the end we will touch upon file protection issues. Okay, so a directory is a file which keeps track of all other files. Okay, a single directory can contain a list of all files in a system. When hierarchical directories are used, the collection of all directory and subdirectory entries define the totality of the file system. You can have multiple subdirectories like that, right? So uh, in terms of computer, we always talk about the capability of the storing the data. So that comes under the file management. So data is, as you know, that it is always stored on the secondary storage devices. Okay, in terms of your hard disk drive. Okay, so the operating system, what it does, it manages the storage and retrieval of the data from these devices. Okay, so data is stored as files in folders. Okay, so all these files are organized in a system called a file system. Now you must have heard there are different kinds of file systems, right? But you must have seen or heard that one, but without knowing, right? Like, see, uh, the operating system, it creates a file system. It follows the certain rules to access and stores the data on it, which we'll discuss. Okay, so uh, like for those systems, it creates the file system called as fat file, that is file allocation table. Or if you're familiar with the file partition, that is that Windows, right? Windows XP or Windows 7, like that, it follows that NTFS, or it also supports that fat file system, like that. So that comes under the file management. Okay, if you you can search more on that particular file allocation uh, tables file systems, okay, from Google. So the files can be implemented on several devices like disk, tapes, and other secondary storage devices. Okay, so basically we perform four basic operations in the file. These are creating a file. Okay, so to create a file, firstly we have to search for the free space in the file system. Okay, that is on the storage devices. So is there available space, like that? So if the space is available, then we make the entry for the new file. So the new file is created. The directory entry stores the name of the file, okay, and its location on the file system and all other informations related to that file. So that is how you create the new file, right, on a folder, like that. So the file management takes care of where, on which folder, on which directory it should go when it is created, like that. So writing on a file, okay, so naming a file, like that. Okay, then reading from a file. So to read a file, again need to name we need the name of the file. So the file management takes care of that. If you want to write on a file, if you want to read the file, okay, so it searches for the location, the address where it is stored, okay, by what name it is kept, like that. So as soon as it finds the name, it has to get the content from the secondary storage device and transfer onto the main memory. So extract from the secondary storage device, and then whichever portion you want to read, that is carried on to the main memory, so that the main memory will extract information one at a time, like that. Okay, so that we have seen under that yesterday, under the topic called as demand page memory management. Okay, in there the term uh, we have not the term that is called as virtual memory. Okay, so main memory is very expensive to maintain. Okay, but so there is a term called as virtual memory, okay, which enables the computer to assume that if the main memory is less, okay, then because of this virtual memory, okay, it lets the computer to assume that the memory main memory is more than that because of the virtual memory. Okay, so like yesterday we have been discussing about uh, under the demand page memory management, right? Okay, loading one page after the other, like that, right? So uh, if suppose the size of the file to be executed is more than the physical memory, that is, let's say your RAM, like that, right? So how will it execute the whole data? Like, let's say suppose like your CD, okay, it is 9 GB, your main memory is suppose like 2 GB. So how will it be able to uh, extract all of that 9 GB data, right? So what happens is that the extra memory goes to the hard disk. Okay, so the extra memory goes to the hard disk. Okay, so and the main memory that is available will extract the information from the data from the hard disk one at a time, like that. Okay, so uh, at the point of time, okay, the processor will execute only those instructions which comes out, okay, from the main memory, and at the same time, okay, the main memory, the from the disk drive, okay, it will extract the information one at a time, like that. Okay, that is with the help of the virtual memory. Okay, so next is deleting the file. So like when the command delete is given, the directory search for the name file. If found, okay, then it will release all the space, and then that can be reused by other files, and directory earned is in entry is invalidated. Okay, so information management is nothing but management of all these files and files directories using the information from the device management part of the operating system. Okay, so now next we have file protection. Okay, in multi-user environment, the file protection is necessary because a file is shared by the multiple users. Okay, so when the file is shared by the multiple users, we have two mechanisms to support the protection, that is password. Okay, so passwords can be assigned, okay, to access the uh, file, okay, or to ward off unwanted users access, okay, or access levels can be given, okay, privileges can be given, like the normal one you have seen, like the guest, okay, the admin, like that, right? So that kind of access level can be given also to the files, like that. Okay, so when a user requests access to a particular file, the operating system checks the access list associated with each file. If that user is listed for request access, the access is allowed. So whenever you see such kind of user access privileges, keep in mind that the operating system already has that uh, system file written in there under that file protection. Okay, so the so till here we'll be discussing today. Okay, next we'll be discussing more on the process management. Okay, so that will be all for today.